this video we're going to take a look at the ShapeJoint operator. This allows us to work in conjunction with a shape collision to create a joint between two different particles involved in that shape collision. We've got this dynamic set already cached, so let's just go ahead and scrub and see. We get these this ball rolling and picking up these red particles, and then we also get these red particles falling here and sticking on this cylinder until the two of them get close to each other and they share a mutual shape joint between a red particle, and it causes them both to stick together. Okay, so let's just go ahead and step through and see what we have. We've got a born rule here, and born's got a matter waves born coming off this plane here, just born there. It's got a matter wave shot, borning a pistol shot all over this plane. And then we've got the swinger. The swinger's this green cylinder guy. It's an object particle tracking because he's got some animation on him. We want the particle to do the same thing. We also have the rolling stone being born up here, this sphere. And we've also got the collision environment, these two planes, the red and the green plane. Let's go ahead and look. We've got a force applied to the gravity bound group. Gravity bound includes both the rolling stone, which is this guy, and the red particles, which are all of these red. So they're going to have some gravity pulling them down. And then finally we get to the shape collision. Shape collision set to work on the collision group, which contains all of these other ones. So all of these are involved. And it actually has a deflector set to be the collision environment, which you can see is not within that same group. So those are those two planes. It's acting as multiple floor nodes basically. And what we've got is pretty standard setups here, except for the contact is type 2, and we also have activate all, so it'll wake up frozen particles, and we've got double the usual collision and contact iterations. But what happens is whenever there's a shape collision, it's going to look at particle A and particle B, and it's going to output the particle A into a couple checks here. We're going to check, is it in the swinger group, which is there, or is it in the rolling stone group, which is there? If either of those are true, then we want to check against particle B. And particle B, we want to check, is this in the red group? This is to filter out things like collision environment. So if collision B is in red and collision A is in either of these two groups, then go ahead and create a shape joint using this shape collision. You have to specify that here. And of type spherical, which right now is the only type. And it's going to create a joint between those two particles, particle from and particle to, with their position information, which is very important. And that's going to be what makes them stick to one another. You can kind of see some of the spherical joint type there as it swings that one ball around. It has some leeway. Okay, so this is all pretty straightforward. Just remember your shape joint needs to specify the actual shape collision operator in your TP tree, which is of course this guy right here. And we should also talk about the single star versus the double star output. Single stars and double stars are kind of processed differently. So if you want to use some single star outputs, you can only use them with other single star outputs. You cannot mix single star and double star. That's not what you want to do. Like you see this collision particle B here, this output comes into this in group. If we had exposed the on input and take a single star collided in there, this is going to result in bad processing and bad logic ordering. So do not do that. That's a bad one. But what you do want to do is go ahead and use any single star together in multiple outputs, or in our case, any double star. So, and we also want to talk about the group ordering here. Collision particle A, the way these sort is whatever the collision combination is between two groups, the collision particle A is going to be the one that's higher up in the list. So in this case, if the collision's between a swinger particle and a red particle, because swinger is above red in the group tree, swinger will be outputted in the particle A, and red being lower will be in the particle B. So just remember the particle A, particle B has to do with the order top down. In our case, collision A, or particle A, we're going to check, is it in the swinger or is it in the rolling stone? And those could be either the choices for particle A, and both of those are higher up than the red particle. We know that red particle will come out on particle B. So, and again, it's just going to check, okay, I've got two collision particles. Is it in swinger or rolling stone? If it's in either of those, and the other one's in the red group, then go ahead and create that shape joint. And you see we use that and to turn this on. Okay, so that's kind of the basics of ShapeJoint. We're going to go ahead and move on and take a look at some more stuff.